as humans, if I say something and you feel uncertain about what I mean or what I said, you typically ask a clarification request. So you might check that you actually understood what I mean before you sort of continue. And this is very sophisticated because we also consider how important is this. If I ask you to play a song, for example, if I ask my smart speaker to play a song from Spotify, it will not check with me first if it heard correctly. It will just start playing because it's the program and designers of this knew that if there was a misunderstanding, it's very easy for me to correct it. I can just say the song again. It will play the correct song next time. But if I would ask it, I can't do that now, but if I could ask it to delete my hard drive, I don't think it would just start deleting. You would, of course, ask me whether I really want to do that.
Hello and welcome. The following is a conversation with Gabriel Skantze, a professor of speech and communication technology at the Department of Speech, Music and Hearing at KTH in Stockholm. Through his research, Gabriel has extensively studied different aspects of implementing language in artificial intelligence. He's also a co-founder and the chief scientist of Furhat Robotics, one of the leading startups in development of social robots in Europe, with the goal of creating robots that are capable of having face-to-face conversations with humans through both verbal and non-verbal communication. Gabriel's work at KTH and Furhat is deeply inspiring as it reveals some of the most fundamental positive effects that AI and robotics can have for society. From teaching at schools to combating loneliness or effectivizing patient data gathering in the health sector. It is an indicator of the great possibilities for humanity in both near and far future. I was deeply honored and grateful that he agreed to participate in this conversation. I am Avid Fayaz, and this is the AI Pod. I hope that you enjoy the program. Why is it important to have social robots?
Yeah, that's a good question because it might not be so obvious why a robot should be social. So we've had robots for a long time working with physical tasks or delivering things like in a factory. And traditionally these robots have not supposed to be near anyone or interacting with humans. But a social robot, on the other hand, is a robot that actually interacts with humans. So if you think about Star Wars, for example, and C-3PO and R2-D2. C-3PO is very much a social robot in the sense that, C-3PO can speak millions of languages and also know about social protocols and so on. And actually, if you watch Star Wars, you see that C-3PO very seldom use the hands or arms for anything. So that they seem to be there for communicative purposes, right? So actually a social robot could be a robot that both do physical tasks and interact with you, where you could, for example, instruct the robot and tell it what to do. But a social robot could also be a robot that doesn't do almost anything of a physical task, but only is there to interact with you. Maybe if you would, for example, go into a hotel at the reception, there could be a social robot there greeting you and helping you to check in. So that's sort of what a social robot is. And then, of course, it's debatable where the line between robots then and other devices go. For example, is my smart speaker, like a Google Home or Amazon Alexa device, is that a robot? Well, some people call them that, and you could debate that. I don't think it's very interesting to draw the exact line, perhaps. But it's obvious that the embodiment of the robot is very important. So even if you just interact with it by talking to it, there is a difference of talking to something which is embodied, like you are sitting in front of me now, and you are here with me, co-located, and that's very different from if I would have talked to you over the phone. So there's a completely different set of signals that we can use in our communication, of course. Yeah.
Yes, and the thing about it is the line, because humans have a tendency to anthropomorphize quite a lot, where should we draw a line between creating robots that we, at least from our perspective, could to a certain degree perceive them as sentient and just an object that we interact with? When in your work in Furhat, do you try to perhaps create robots that from at least a human perspective can be viewed as to a certain degree sentient? Although I know we have to be clear, they're not sentient, no, but from a we quickly try to reflect our own perceptions to objects. So is that to a certain degree maybe a goal?
To some extent, yes. I mean, clearly Furhat is designed to look like a human. You can project other or make it look like an animal or more of a sort of traditional mechanical robot if you want to, because it's a projected face, so you can actually project what you want on it. But it is typically the way we use it. It's quite human-like. It's not as human-like perhaps as those robots you see from Japan with a sort of artificial skin and so on, which are sort of more human-like. Furhat is a little bit more cartoonish in a sense, and of course it doesn't have a body, so that makes it less human-like in a sense. It's only the head. But that's a very important question. Like, to what extent should we make robots human-like? And there are a lot of arguments in both directions for why you would want to do that, and also why you would not want to do that. I think we could, of course, if you want, go into those arguments. But I think the main argument from my side in why we would want to make them at least somewhat human-like is that we know how to interact with other humans, of course. We are programmed from evolution and learned from birth how to interact with humans. And of course, if we meet a device that looks like a human, we will try to interact with it using all the same ways that we are interacting with humans when interacting with the device. And if the device actually responds to that in the right way, of course, that makes the whole interaction much more intuitive, potentially, compared to a sort of non-human-like device.
Yes, and I think maybe if someone were to try to argue against you, they would say that that is a slightly false perception. I mean, the story of the Google developer that started believing that the BERT system at Google had some sort of consciousness is quite famous because it was so human-like, the interactions and the use of language with that language model, that he started believing that this system had some sort of a consciousness. So if someone were to try to push back on the position of trying to make robots that are at the end of the day, at the current state at least, complete objects, there are slight, perhaps, dangers from a human perspective to that.
Yeah, absolutely, and that's a great point. But there is a big difference of sort of behaving as if something was human, or human as a human, and thinking that they're like a human. So I can behave in that way towards a robot and talk to the robot as if it was a human, while I still know that this is not a human. I think you can maintain that distinction, but I agree that there is a danger that not all users or humans will do that, and that they will be led to believe that it's an actual human, and that there is a danger there. I totally agree. So I think that's something to monitor and think about when designing robots. And there is a danger if you too much try to. I mean, if you take the Google example with the Lambda chatbot, that chatbot if you ask it, are you sentient? I mean, that's what happened, right? So I asked the chatbot if it was sentient, and it said, yes, I am, and so on. So it sort of really led the person to believe that. It could also have said, of course, no, I'm not sentient. So if you chat with another chatbot like ChatGPT, that has been a lot on the media, ask it will say, no, of course I'm not sentient. Even if you ask it, how are you doing, it will say, I have no feelings. I'm just just a chatbot or a language model. So I don't have any feelings. So that's also a route you can take. Still, the way you're interacting with ChatGPT is human-like in the sense that you're using natural language. So you don't have to think about how should I communicate, what are the commands that I should give. Just use natural language in the way you would think you should use it.
Yes, so now we're going to the next point and touching on the importance of language to the whole of this. So what is the importance of natural language processing to creating a social robot?
So that's also interesting. I think traditionally in the field of social robotics or human-robot interaction, a sort of verbal language hasn't been so prominent, perhaps, partly because it has traditionally been very hard to process sort of verbal. With verbal language, I mean when we're using words to communicate. So in a written text, you have almost exclusively what we call verbal communication. In spoken interaction, there is a lot more. So if we have in the voice, of course, you have prosody. So that's the tone of your voice. So maybe the melody of your voice, the intensity. I can prolong things, and all of this will add meaning to what I say and help to also coordinate our interaction. Things like turn taking. And all these things. How do we sort of manage this? And all of that is none of that is in a written chat. So that's very different in a sense. And of course, if we are sitting face to face, you also have all the visual cues like the gaze and the facial expressions and so on. But of course, the NLU that you're talking about, that's about the verbal aspect. So that's the words we are speaking. And these have been traditionally sort of two separate tracks. People doing processing of verbal information, that's what you call computational linguistics or natural language processing, versus people who have more looked at the nonverbal signals. Of course, there is now a lot of work to put these together, but that's actually quite challenging because it's has traditionally been quite different techniques for doing that. But yeah, the answer to your question is yes. Natural language processing is, of course, extremely important in a human robot. I mean, you don't just want to raise your eyebrows and so on to the robot. You actually want to talk to it and make it do things and answer questions and so on. So in some sense, that's sort of very central.
And yes, you mentioned NLU there, which stands for Natural Language Understanding. The debate on whether NLU exactly, to what degree NLU exists, is perhaps quite heated these days, especially with consideration to ChatGPT. Some say that our current transformer models that are being used do not necessarily have an understanding of language so much as they have been trained on these large corpuses and have developed a degree of contextual understanding, but not a true understanding of what language exactly is. And just for the listeners or the viewers, I have to say that humans, for example, learn that I'm holding a pen right now. A pen is a pen through learning, through thinking. Whereas a robot or a AI that you want to train, you have to train it through showing it thousands of pictures of a pen and hundreds of thousands of or millions of pictures of what is not a pen and teach it on that. So it learns by example. So the question is, can you create a social robot, an advanced social robot, even without having that sort of a natural language understanding through only sentiment analysis?
Yeah, it's a lot of things to unpack there, because I think to some extent, of course, humans also learn by example. So we also...
Yeah, I mean, that is quite true. But I mean, if I were to express to a relatively normal human being what a pen is, I think that human being, if shown another pen, will to a certain degree understand that is probably also a pen. Whereas a robot needs to have very many examples to be able to
Exactly.
do that.
So I think, yeah, the main difference there is perhaps not so much the fact that we have to learn things through experience, but that humans are much better at generalizing. And there are a lot of things there that are important, but some people have pointed out that, of course, one we as humans at least are very good at learning rules or inferring rules. So if we see a pattern, we can infer a rule based on that. So for example, when we learn math, we start counting and so on, but soon we understand the principle behind counting, and then we can apply that no matter where we are in the number sequence, and we can do addition and so on. Whereas if you, as many people have tested these language models, they are only trained on predicting the next word in text. And they can do some math, but clearly they can't generalize rules to the same extent. It's very hard to know, though, because we don't really know what the training data was. We don't know exactly which examples it has seen. It has seen billions of texts on the internet. I don't know exactly what things it has seen. So maybe if I give it a test I think is quite tricky, maybe the exact same test it has seen, I have no idea. So it's very hard to know, but it seems very clear that it can't generalize math very well. It can do simple math, but not very complex math. And that's because it hasn't learned these generic rules. And humans are very good at that. So I think that's a very big difference from how these models work, from how humans work.
Yeah. And you recently, or not so recently, but you published a paper named Galatia that was published in a paper. And for those who don't know, Galatia is the figure in Greek and Roman mythology of the story of Pygmalion, who's sculpted, and this sculpture named Galatia comes to life. And we in AI, I think, like to refer to Pandora and Galatia quite often. But when it comes to language and error handling and ambiguities in language, what are the current solutions that are used to solving those issues?
Yeah, that's a great question. Actually, my PhD thesis was on error handling in dialogue systems. So that's a topic I think is super interesting. I think one of the reasons this used to actually be a bigger topic than it is today is because speech recognition, that turns speech into words, which is a very important part if you're building a dialogue system, used to be really, really error prone and bad. So how do you deal with those situations where the system constantly misunderstands you? How should the system react and so on? So that was the topic. And this was like 15 years ago or so. So of course a lot have happened since then. But actually if you look at modern chatbots or language models, they are not explicitly learned to handle errors. So they don't typically, like as humans, if I say something and you feel uncertain about what I mean or what I said, you typically ask a clarification request. So you might check that you actually understood what I mean before you sort of continue. And this is very sophisticated because we also consider how important is this. If I ask you to play a song, for example, if I ask my smart speaker to play a song from Spotify, it will not check with me first if it heard correctly. It will just start playing because it's the program and designers of this knew that if there was a misunderstanding, it's very easy for me to correct it. I can just say the song again. It will play the correct song next time. But if I would ask it, I can't do that now, but if I could ask it to delete my hard drive, I don't think it would just start deleting. You would, of course, ask me whether I really want to do that. So that's a very important part of this error handling. We are very aware as humans of how important is the task that we are engaging with, and to what extent should I try to clarify things and so on. And this is also like when I'm speaking, you are nodding to me, you might be doing what we call back channels, like and so on. That's also part of all these error handling or feedback system that is in place for us to maintain successful communication. And this is more or less completely absent from these language models. They just produce what is the likely next thing to do. So it thinks that, okay, in this situation, it might be likely to ask a clarification request or not. It doesn't do that because it is uncertain about what you said. It has no notion of whether it's uncertain or not. It just randomly samples from things that are appropriate to say. And that's, I think, something that people will look more into because that's clearly sort of a limiting thing in current systems.
And also perhaps a very important step towards a much more advanced understanding of language.
Yeah, definitely. And I mean, people are already seeing this. If you ask ChatGPT questions, factual questions, it might very well just fabulate something and make something up. And it sounds very certain in its answer. Because again, it doesn't have really a notion of how well it knows things. And it can't use that to reason about things, its own certainty in things. There's no like meta processing like that. And yeah, humans do that all the time. And that's how we ensure that we don't just say completely false things or that we fail with our tasks and so on. So yeah.
And even perhaps we always have a slight amount of doubt in ourselves about, even when we are certain about something, that
yes,
might be wrong about something here.
And that's of course very different. There is this joking expression called killgissa, or in Swedish, which is a tendency for men to be more certain of what they say than women tend to be, or at least that's the general thought. And so yeah, it varies between people also how much we sort of take risks and how much we are sort of want to check things first and make sure that we get things right before we proceed and so on. Yeah.
I think now we've covered the subject of language in its verbal form to a certain degree, and language in its verbal form has been studied for perhaps thousands of years by different writers, or at least their thoughts on it have been expressed in different manners. But you also work to a certain degree with something that is so complex perhaps that no one even has tried in the past. They have tried to understand it to a certain degree just in the past century. One of the first instances of trying to understand non-verbal communications is by Charles Darwin, I think, in one of his books, The Expressions in Humans and Animals, which was published in 1872. And that is a realm which is filled with so many ambiguities and complexities that now we are moving toward with the modern facial recognition techniques. But what are the methods for creating systems that can recognize patterns in humans' faces and even body language, and what importance does that have in creating more socially capable robots?
Yeah, I think that's very important, and one way to sort of show that that's important or is to think about like, as I said earlier, we as humans think it's much better to meet in person or at least have a video link compared to just the voice. And of course that shows that there is something there that is important. And also I should add to that, because you mentioned verbal communication, but I think in many cases, as I also said earlier, there are non-verbal aspects of speech, which is, again, the prosody, the tone of our voice and so on, which is also extremely important, and that is traditionally neglected. So there has been such a big focus on written language. That's sort of traditional computational linguistics and so on. The written language is very central. But actually, if you think about it, written language is a very recent invention. It's like 5,000 years old or so, whereas humans have been speaking to each other for at least 100,000 years. So that's the actually original. And you can think of written language as a technical innovation to approximate what is the actual thing, which is the spoken interaction. So it's just an approximation. It's a much, much poorer approximation of what is the real spoken interaction. Again, that's why we prefer to speak to each other. But yeah, back to the processing. So yes, of course, these things have become much easier to do now with than it was like 15 years ago. Now that we have deep learning techniques, where we can just train models on data to infer things from the face and also the voice, so we can do speech processing in a much better way to extract the things like prosody and so on. Just to take an example, we are in our research very much interested in this thing, turn taking, that I mentioned before. So how do a speaker know that they are supposed to speak and not, and when is the next person's time to speak? And if you look at humans, they are extremely good at this. So the sort of typical gap between two turns in a conversation can be around 200 milliseconds. And that's extremely fast. And considering also that we have to think about what to say as a response to what the other person said. Like, you can't just come to think of something in 200 milliseconds. So people are also, while you are speaking, I'm preparing my response. I'm predicting what you are about to say and how your utterance will end, so that I can start my whole machinery of preparing a response. And once I detect that you're done, I'm ready and I can go. And that's just amazing how the human brain can do that, all these things simultaneously. And of course, in order to do that, we need some coordination signal. So I need a signal from you to know that you're not just pausing. Maybe you're pausing to think of something. And I can notice immediately that it's not my turn to speak. Now, machines are extremely bad at this. So you often, they are just listening for this silence. So if you make a pause, the machine might interrupt you and start speaking. Or it might be very sluggish, so it's much more than 200 milliseconds, of course. You have to wait for it to respond to you. And this is something we want to improve, and there these non-verbal signals are very important. So we listen for the tone in the voice of the other speaker to detect when it's my turn to speak. But also the visual channel. So I can see from your body language to what extent you want me to speak, or if you want me to give feedback, for example. For example, a gaze. So if you are making a pause, you might gaze away. And I will interpret that as a signal that you want to continue speaking. I should wait for you. Whereas if you, towards the end of the utterance, you look up at me, then I know that it's sort of the turn should pass to the other speaker. And then we combine these in a very sophisticated way. And that's where we use deep learning techniques to be able to sort of extract all these signals to be able to make those predictions and possibly make a robot that is extremely good at knowing exactly when to take the turn, when to give a feedback, and so on, to have a much smoother interaction that is possible today.
Now I'm slightly hyper-conscious about all my non-verbal communication.
Yes.
Because every time we discuss these type of things, I start thinking, how am I using my eyebrows or hands? But you discuss a lot about tonal patterns and listening for humans and how they speak exactly, when they pause, when they perhaps take their voice down or up. And of course the current assistant bots are much more just in the form of you have to give them an order or something like that to be able to interact with them. But how do you use that system and implement it also in a robot? How do you create machines that can have varying degrees in their tone and speech, or even their reactions to our conversations?
Yeah, so there's a lot of components involved there, and one there is, I think what you're talking about is the speech synthesis, for example. So how do we control the robot's way of, so it's one thing that the robot should be able to read your expressions. It should be able to pick up you through the camera, through microphone and so on. But it should also, of course, the robot should be able to express all those things, so that you know if the robot sounds uncertain, if the robot is just perhaps making a pause and wants to continue speaking. And this has traditionally not been done. So it might say something, and you might very well misinterpret what its actual intention is, or you might accidentally interrupt the robot because there was no clear turn-taking signal from the robot. Speech synthesis has traditionally been trained on someone reading, like a newsreader or sort of an audiobook, someone reading a text. And then you basically train that on large amounts of text and speech data. But that's, of course, very different from how we speak in a conversation. So in a conversation, we have much more things going on, and where what I say is dependent on what you said and so on. And we use different tones in order to express things like turn-taking is, of course, absent from an audiobook, basically. But also things like feedback, like when I give acknowledgements and so on to you. And I use different tones of my voice to maybe sound surprised or sound uncertain and so on. So we really need to train this system. I think the way we train it is similar. It's just that the input has to be much richer than just the text that it's supposed to speak, but also what is the robot's intention of what it wants to say, and what is the context in which this is said. So that's, of course, research that is being done now to sort of add those things also, and not just make it sound like a newsreader.
Yeah, it's the number of parameters that have to go into making this a possibility, both from an analysis and observation perspective from a robot, but also implementing it in a robot there are so many different factors that need to be, a robot needs to be trained on to be able to do this, that it sometimes looks like a gigantic task, truly. But how do you see the outlook for this being possible in the future? Or is it a new future, or is it a mid to near future?
I think, first of all, I think there is this idea of creating some kind of generic social robot or conversational system or chatbot that can just do dialogue, whatever that dialogue is. And I think that's a misconception. So I think we have to think about much more specific use cases. So if we think of, what if we do a robot that works in a hotel reception, or maybe a robot that makes interviews. That's something we have looked at, like a robot that can do an interview. Or a robot that simulates a virtual patient that doctor can train with. That's another use case we're looking into. So if you look at a specific use case, then the problem becomes much more manageable, because then you can collect data of perhaps people doing interviews and train models on that. And then you're much more likely to succeed. But the problem is, I think, what is really, really hard, or not perhaps impossible, is to have this idea that you're going to do some kind of general purpose thing that is going to do everything. And that's just unrealistic. So I think we have to think, at least in the sort of mid-term future, to think more about what is this robot for, or what is this system for. And once we know that, we can start to narrow down the problem, and then we can also do it in a much more sophisticated ways and take much more things into account.
But are your training systems, the interviews, do you think they are the right data? Because these robots are, or these AI systems are, to a certain degree, by some publications, been called parrots, basically. They are very complex parrots. Do you think that there might exist a risk for having a slight incorrections in the data if humans, when they're known to being perceived, behave completely differently, perhaps, to when they are in a normal conversation without any microphones or cameras around them?
Yeah, to some extent they are parrots, of course, if you train them on data, but it doesn't only have to be that. I mean, that's the sort of traditional way of doing machine learning. You have a big data set of people talking, and then you just build a model, and then you have a robot talking like people. And of course, there are many problems with that. One is, of course, that people are not always a good model. So, for example, people have built these chatbots based on how people talk on Twitter, and it becomes an awful chatbot because people are awful on Twitter to a large extent. So you really have to teach it how you want it to behave, and that's actually one of the advances that they made with this ChatGPT. Is that they not only trained it on all these texts that you found on the internet, but they actually used humans to train it, to give it examples to humans of its output and ask humans, do you like this kind of answer? And then humans can tell that if it's saying things that are racist or other things that you don't want it to say, you can tell it this is not a good answer. And then it will learn to conform to those norms that we sort of give it. So it is possible also to sort of teach it how we want it to behave and not just act like a parrot in that sense.
Yeah, and the thing about that is that for a very long time we have had AI from the 1960s or something about that, 1950s. And there have been winters and there have been so-called springs in the AI technologies, but what has really been the cause of the breakthroughs has been these unsupervised systems that just take in humongous corpuses and analyze them. Don't you think that there might, I mean, if we go back to the system where we have to start doing rigorous testings of supervised testing on their behavior, there's a slight drawback to the speed of the innovation, or perhaps that's a good thing to have a slight drawback on the speed of the innovation if it means that they are slightly better and less.
It's also depend on what you mean by speed of innovation. It's not necessarily innovation if you are doing something that behaves in a bad way. It might be sort of an illusionary innovation that we are proceeding, but we are not creating things that are useful for people. Or I think there is a general trend, or there will be a trend towards also systems where you, as I said, try to do more focused tasks. Like very recently, Meta released this or published a paper on their Cicero system that could play the game of diplomacy, which is a board game that not only involves strategic moving of pieces on a board, but also communication with the other players. So you have to form pacts, you have to be able to negotiate, to persuade, and maybe even bluff in order to win this game. Actually their system sort of, it was on the same level as the best humans, which is really, really fascinating because it actually has to use natural language in a way that is very, very interesting. And in a way much more interesting than these chatbots that just respond to questions and so on. But the interesting thing with that system is, first, it's a very, very constrained task. It was trained specifically to play this game, but it's also built in a very sort of modular way. So it uses reinforcement learning and planning and a lot of different components in order to do this task. It's not just trained on a large corpus of diplomacy games, which would be this sort of more straightforward end-to-end brute force approach. So I think that hints a little bit towards what we will see more of, more constrained, more modular things that is perhaps also much more interesting and useful to us.
That was so fascinating about the diplomacy and Meta's AI system, because it, compared to the DeepMind's Go spelling or chess spelling AIs, it didn't rank as the highest ever player in its history, as it was the case with Go and chess. It ranks with the top players, which perhaps indicates that as we get closer to a better and more advanced systems that can have multi-factor processings, they become a bit less, a bit more like us, and less this just completely super being that is capable of doing extraordinary things. It is, of course, extraordinary what it has achieved, but we draw them back to our level of humanity to a certain degree as well, because we have to combine so many different elements into it, and the ambiguities start rising in these type of tasks.
Yeah, I totally agree. I mean, I think there is such a big difference between implementing a game like Go or chess, where it's only about the strategic decision, and then it's almost like a calculator. Of course, it can do much better than a human if you just give it enough compute power. But this is about, again, negotiation and persuasion, where you involve other humans into your strategy, and especially through natural language as an interface. That's clearly something very different, and where we don't. It might very well be that this is just a step, and it will be superhuman at some point, but it's a different type of task. Clearly.
And about this interacting with multi-parties, me and you are sitting and just interacting, the two of us together, and are completely focused perhaps on each other's speech and nonverbal communications, but when you involve multiple humans or even robots in the same conversation, suddenly the system becomes even more complex. How are the approaches to creating, assigning the right emotions to the right humans, the right tones of conversation in a general conversation amongst different entities in your work? Multi-party conversation is interesting. We have studied that quite a bit. It's also one of the cases where a robot makes more sense than a smart speaker, because if you're several people talking to a smart speaker, the smart speaker wouldn't know if, first of all, hard to say who is talking, but also who is addressing whom. Now it's very unclear. It's like having a telephone conversation with a lot of people in the same call. It's would be very messy. But in a physical situation, it's sort of back to the turn taking that we talked about. So that's tricky when you're two, but of course even more tricky when you're several people, because it's just not enough for you to recognize that I have done speaking. You also have to think about, should I speak now, or should I let someone else speak? So if you're the robot in such a conversation, you have to think about, someone said something, should I answer that, or should the other human answer that? So for example, we have a game that we have also tried to use for a language learning setting in schools, where the robot plays a game together with two humans. And the nice thing there is that the humans can also discuss with each other. So they are trying to solve a problem together, and sometimes the humans might help each other, and sometimes the robot might help them. And that's a very, very interesting setting, I think, especially if it's like language learning. Maybe sometimes the other human would know, and maybe they would learn from actually helping the other person. But sometimes the robot needs to jump in the conversation and so on. And there are a lot of interesting factors. One, of course, is the robot should know when to speak, but also what if the discussion is imbalanced, so that one person, if it's two children, speaks much more than the other. The robot can try to make the other one talk more. So you can, by just having, we have seen this, by just having the robot look at the other person, they will start to contribute more to the conversation. So the robot can have a lot of interesting roles. But will the problem of training the robot on the right data become even clearer there? Because you can have a robot that jumps in every conversation at all times, or can you control to what degree this robot engages in every conversation? And what should even the protocol be about this? How much should a robot be engaged in a conversation if there are multiple human beings that are having a discussion?
Yeah, so we don't typically train the system like in this end-to-end way. We typically can control these things, so we can sort of decide how much the robot should try to jump in and not. And I would say that depends entirely on the task. Like, do you want the robot to be sort of leading the discussion, or do you want to let the robot take a step back and just monitor the interaction and see what happens, and maybe just jump in if it can actually provide some extra information or so. So yeah, I would say that depends on very much on the task, and that's again the strength of not only using end-to-end approaches, but to actually have more control over the system, where you as a designer can also affect those things.
But what do you think in the near future are the most important tasks for social robots? Do you think in the health sector perhaps, or in schools, as you said, maybe between children?
Yeah.
Are there any applications at Furhat that you guys might be looking into in the very near future?
So actually, I mean, Furhat as a company is a platform company. So the whole idea is that Furhat is a platform. It's not, some robots are developed to do one specific task, and it's designed towards that task. But actually, Furhat is supposed to be used in a lot of different situations, and we are creating the platform in a generic way so that people will actually be able to come up with new ideas that we never thought about. And we are of course using it at KTH also in our research. And I think there are tons of applications that are very interesting. I think we are testing it for, as I said, language learning. We have used it in schools to see if it can teach English to Swedish students. And we have another example where it's where we are project together with Karolinska, where we are looking at using it, as I mentioned before, as a virtual patient, so that doctors can train to talk to patients and ask them questions in the right way, and then make a diagnosis of the person. So that's super interesting, and a very nice application, I think, of these language models, because we can sort of use it to create a very free-form interaction in these kind of settings. And another example is a project we have where we are looking at putting robots into autonomous buses. So in the future, of course, if you have autonomous buses, there is no human there to sort of represent the bus. That you can ask a question: what if the bus suddenly stops? Who should I ask? What happened? Or other kind of questions that you might have. So one natural solution to that would be to have a robot on board the bus that people can talk to, ask questions. But also an interesting side effect of that is that you can imagine that walking up late at night on a self-driving bus with no person working there, and there's just one other passenger, and you feel a little bit of a threat from that person. It's not very comfortable setting, perhaps, to sit alone on a self-driving bus. But what if there was a robot there? Will people behave in a more sort of nicer way if they know that there is another sort of social entity in there? I think that's a very interesting question also. So I think, we could really think about what kind of functions these robots can have beyond just sort of answering questions. Yeah.
It's very interesting to think about that question of safety, as you said, because just the thought of there are, of course, many science fiction references to this case that you mentioned. In the majority of those cases, when there was a robot involved and two people, the robot didn't turn out to have a very good outcome for it written out. But of course, I think there's really interesting potentials in terms of just applying these robots as a means of observers for to perhaps create a more safe environment for people to feel that they just, if in the worst case scenarios, have someone there. But there are now many companies working to a certain degree or another. The two main ones are Tesla and Boston Dynamics on humanoid robots. Tesla is working on the Optimus robots, and these are becoming more and more capable at doing different tasks, although even they claim themselves that the biggest challenge remains the artificial intelligence part. And you began this talk with talking about C3PO. How close are we to putting a head that can express emotions on a robot and just having that as an entity in society? And what do you think are the implications of that for us?
Yeah, I think.
I mean, this is. I do apologize. This is a slightly going to the science fiction realm of it compared to the science part of it, but it is very interesting just to see what people that are in the field think about the potential, very perhaps slightly longer term potentials of this.
Yeah, I think it goes back a bit to what I said earlier about sort of more specific, not general purpose robots. I think robots that can just walk around in the streets and or just do general purpose things, that's very, very far away. Like even just a robot that, I mean, it would be fantastic to have a robot butler in your home, right?
Yeah, I mean, that's basically the reason to a certain degree that I asked that is Elon Musk, as always, with slightly ambitious timelines. He thinks that maybe that will be a possibility, that you'll tell your robot to go and grab you a bottle of milk at night.
I think that's very, very far away.
Yes.
So I think as long as we build robots for very specific tasks, like there already exist robots that work in like warehouses and so on, that's fine, and they can be much more advanced than they are today. But the idea of a general purpose, like, or let's say a robot working in a kindergarten, I mean, I think that's very, very far away. I mean, just think of all potential situation and all the social codes that you will need to read and understand and react to, and all, of course, the physical manipulation tasks involved and so on. It's just very, very far away. I can't, like, it's impossible to say, given where we are today, when that could possibly happen.
Yes, and I think there are a lot of researchers that hold the exact same position, but at the very same time say if we keep on doing more and more tasks, maybe we can combine them all together to be able to create more general purpose robots. That's
I am as you might suspect, I'm a bit
Oh, okay. So you're on the more hesitant.
I'm more on the hesitant side. I'm more thinking about more specific purpose things than general purpose things. I think that's a more realistic path, at least for the foreseeable future. And of course, you can debate what is specific and what is general. I mean, ChatGPT is somewhat general in a sense. It can answer questions about a lot of things, but it's also a lot of things it doesn't want to talk about. So, and it can't do for you. So, it's also constrained, clearly. So, things will open up, but they will continue to be targeted towards certain use cases, I think. Yeah.
And at last, I have to say and ask, do you think robots are coming for our jobs? I mean, there are many applications even right now that there is, of course, resistance amongst humans of robots becoming more interactive with us throughout our daily lives and taking people's places in offices, or even in a perhaps reception area. You could have a robot that takes in people, but there is a larger and larger debate when it comes to robots such as ChatGPT. It's just a lot of programmers, a lot of people that do tasks that are even at the moment completely possible to be done by a robot, to be replaced. Do you think?
I mean, of course, to some extent, that's natural evolution with technology. Jobs change, and people will use these technologies, of course. So the way they are doing their job, like if you're a lawyer, the way you do your job using things like ChatGPT will, of course, change the way you do your job. might also change the number of lawyers we need. If they have access to very advanced technology, they can be much more efficient. But it's not always clear that it means that there are less job opportunities. It can also be that the demand increases. So, for example, if I would have the robot butler in my home, nobody would be unemployed because of that, right? Because I don't have a human butler in my home currently that would be unemployed. And that goes for most people, and that's like a lot of robots. If everyone wants to have maybe a few robot butlers in their home, even, so it's not necessarily the case that new technology always like replaces one human who did that job before, but certainly the way people do things will change. But yeah, the number of jobs it's not necessarily affected.
So, thank you very much for that. I do apologize about the last bit going a bit too far into the future, perhaps,
No,
but
that's very interesting.
it is very interesting stuff that is coming at a very interesting pace. Just in the past 10 years, we've seen so many breakthroughs, and just makes you be very hopeful about what's coming in the next 10.
Yeah.
So, Gabriel Skantze, thank you very much for participating in the podcast.
Thank you very much for inviting me.